It's a wide variety of different clients, different structures, different sizes, different industries, and different technologies as well.
The world we live in now is just so many light years above the world that we were working with even 5 years ago. We get into lots of topics deeply, and it's fascinating how it all works and why it works. You know, we get paid to make fancy jigsaw puzzles.
Access granted.
Developing software is a unique opportunity to be creative and technical at the same time. It gives you the opportunity to solve problems. It gives you the opportunity to exercise and flex your mental muscles by solving problems and figuring things out while also being creative.
You can feel that energy when you come into the office. There's a really good vibe and connection between everybody who works together here. It's really collaborative, and we even have the tools for doing that collaboration now as well through Microsoft Teams. We always try and team up in pairs where possible for client work. 2 heads are always better than one.
I believe being a developer, a good developer, is writing good quality code. But being a great consultant, which we are at SSW, is half-half between technical skills and communication. That's what makes us different on the market. That's what gives us our edge, because we're capable of not only doing great work in terms of technical skills, but also bringing value and bringing our insight based on our experience, saying, oh, to solve this problem, I would recommend you going that way or this way, and bringing that value, that strategic value to a client, and being able to phrase it, not only having it in your head, but phrasing it to give them options.
And we make sure that people are communicating internally with each other in a way that is professional and succinct, and we make sure that that's the way that we communicate with our customers as well.
And I want to show you a few ways that make email more useful.
People that want to improve their communication through public speaking can do that through the conferences that we're involved in. They can do it through SSW TV.
You might actually not need to go native, guys.
We have a lot of videos that kind of help get your face out there, to get your name out there. We also have a really good social media presence. We have a great marketing team that takes care of that.
We are client-facing all the time. There's no way to work at SSW and just be behind the desk and not talk to anyone. Every day you have to communicate. So that brings communication as a core skill of what you become. And some people develop it a way further, like by doing public speaking. We have awesome speakers. I think NDC videos prove that. We have awesome tech tips and even conferences given by SSW people. I think we had like 6 or 7 this year, so that's pretty huge.
One of the exciting things about working here is we're always on the bleeding edge of technology. We're always trying to reach out to those new projects. What are other people doing? What's the next best thing? I think Adam being a Microsoft Regional Director really gives us a bit of an edge in that regard as well, because he usually knows what's in the pipeline before other people do.
We've had many younger guys come through SSW, and in a few short years, they've become absolutely amazing developers.
You can have guys with just a few years of experience, and they're building software that's affecting tens of thousands of users with some guidance of the software architects. It just works. It's amazing. You build something and you test it that you can enter an order, and then all of a sudden you can enter thousands of orders in seconds. It's just incredible. We couldn't do that a few years ago.
We have a couple of different ways that we socialise. Every lunchtime, we're killing each other in board games, which is always good.
It's interesting because those games, are about psychology. That's very interesting. You learn a lot about people.
The most exciting thing that we do is obviously our company retreats. We go away for a weekend after doing a brainstorming session. On the Friday, we all work together as a group and work out, problems for the company itself. We always try and keep the activities a little bit different to make it a bit of fun.
It's just a great weekend all around.
People that come to work here want to be at that level of globally recognised expertise that some of the best guys at SSW are at. And even if you're not at that stage now, I think that a lot of people that come to work here are inspired by that.
A lot of clients come to us with maybe a general idea of what they want. And you can use your expertise and past experience to really inform their decisions and make sure that they're developing the best possible product. I really enjoyed that part of it, and I think that would be very satisfying for anyone who's been working on maintaining an old piece of software or maintaining an old system. If they could come and maybe work on some new greenfields projects and potentially, influence the way that product comes out at the other end.
You can come up with cool designs, you can come up with new solutions, you can come up with elegant ways of solving problems that haven't really been done before, and plus you get to build something. And often the projects that we're engaged with, you get to build something that's going to make a difference.
People want more stuff automated, they want richer interfaces, they want bot interfaces. The architecture keeps expanding, the knowledge of Azure keeps growing. Like, I'm still learning. I'm still trying to get better. I'm still trying to make solutions quicker, more maintainable, cheaper, and there's a long way to go.
True competitive personality only comes out on retreats. Like we go on a bushwalk, or we play tennis, or we go swimming, or we go go-karting, and all of a sudden he's just like, get out of the way!
Thank you very much for coming in, guys. I hope you all enjoyed your rides today, and I hope we see you all again, guys.
To SSW.
Hello and welcome. I'm Bryden and I'm going to be talking to you tonight about top database performance techniques. All right, so let's get started. So a little bit about myself. I'm a solution architect here at SSW. There are my social media links. On top of that, I've been coding database performance products for 20 plus years, and I've been coding for 42 years. In fact, probably 43 years by now. I've worked with Azure since it launched just over 15 years ago, and I've used Azure at very high scale. So if you've got any questions about Azure, feel free to hit me up after the presentation. So, the presentation and all of the demos here are available at that link. That'll come up later in the presentation, but just so people don't feel they've got to grab stuff as they go along, I'll just make it clear. So, what are we going to cover tonight? So, what we're looking at is how we can improve the query performance. We're going to show lots of little demos, and everything here is going to be a simple technique. So it's something that, as a developer, if you don't have a database administrator in your organisation, these are the sort of techniques you can use to try and improve the performance before you have to escalate and try and bring someone in to help. So hopefully this will help you in all of the applications you write, because all of these techniques are dead simple. And where possible, we'll measure the improvement. And hopefully that's one of the things you'll get out of this, is understanding how to measure database performance, particularly on SQL Server, because we're focused on SQL Server tonight. But there are equivalent techniques for getting the performance information on basically all the major database platforms. Okay, so the first useful trick I'm going to call out is it's always really useful to get query I/O statistics, because that's what you use to measure how expensive a query is on a database server. So in SQL Server, if you run set statistics I/O on before your query starts and then run your query, then you'll get I/O statistics back with the query results. And we'll see this in the demos, so don't worry too much about what that actually means, and I'll call out which things you want to look at in those I/O statistics as we go along as well. And there's loads more little things in those demos, so keep an eye out for other little things that you didn't know about that you might learn as you go along. Okay, so the other thing I'll call out is all of the examples today are using Stack Overflow's database from 2013. So if you're going, this is a great database, it's about the right size for a sort of desktop or laptop machine to go and actually see query performance being bad without it being so bad that it takes, half an hour to return results. It's taking sort of 30 seconds to, a couple of minutes, and then you can tune it and get it down to sub-second. So it's a great database for this sort of presentation, which is why you see a lot of database training is done on this database. And we'll show you where to get this and how to set it up right at the end as well. So, into the techniques. So the first technique we're going to talk about is the most obvious one. Reduce the size of your tables. And why do we want to do this? Well, the first one is it takes longer to read a big table, and it takes longer to do anything to it. If you need to insert a row, it takes longer to find that row and then insert it in the right spot, and so on. So that's one reason you want to keep your tables smaller if you can. The second one is that they take up more buffer space in your database server. So what is buffer space? Buffer space is where the service, it's the memory cache the server has of all the database data pages that it's got in memory at the moment. And what it does is it just keeps as many of those pages there ready to use without going to disk as it can in its memory. So if you have more pages in one table, that means less of your tables will be in memory at once. So that means things will perform worse because they'll have to go out to disk and get fetched back to be able to be used. So now we know that reducing table size is a good thing to do. What can we do to achieve that? So the first example I'm going to give is the most effective. It's not necessarily the one you'll be able to action, but I'll give an example of one customer I had who had about 20 years worth of sales data in their sales database. On inspection, and that database was performing appallingly, on inspection we found out that the only querying they did out of the transaction history table, which was the one that was causing all the problems, was of the last month's data. So it looked at the last month of transactions for a user, and that was as far back as they could go. And yet there was 20 years worth of data in this thing, and a bunch of indexes that had to be updated every time you inserted a transaction, or if you needed to read some data. So what do we do with that customer? We archived all of that data out to another table that they could use for reporting if they ever needed to report on all the old transactions, and kept just over a month's worth of data in that table. And the queries went from taking minutes to execute back to sub-second. So the customer was really pleased. We didn't change any of the functionality in their system, so everything still worked, and yet it was, of the order of hundreds of times faster. And it was just a very easy change to make. What's another one we can do? We can reduce the size of columns. And by that I mean quite often when you're creating your tables, people will have, say, a percentage expressed as an integer. So it's between 0 and 100. they'll stick that in an int64 column. So they're using 8 bytes instead of 1 byte for that number. That's an easy one. Makes, if you've got strings, if you know how long that string's going to be, if it's got, say, a fixed length, like a telephone number, very often you see telephone numbers set as 500 characters long in databases. Completely unnecessary. Like 20 characters is plenty for a phone number. The next one is databases over time tend to accumulate columns in lots of the tables. And most of the time, a significant number of those columns are never even used. And removing those allows the database to compact up, and you're getting more rows into every database page, and therefore you have to do less reading and writing from disk as a result. Anyway, let's see an example of this. So in this example, there's 2 tables, and we're going to use the votes table out of the Stack Overflow. So this is how many people have voted on someone's answer to a question in Stack Overflow. So the votes table contains all of the votes over the entire time, and votes 1,000 contains only 1,000 of those votes. So you'll see we're going to set statistics IO on before we run, and then we're going to select all of the columns from votes 1,000 and then votes. And away it goes, and you'll see the first one, which was the votes 1,000, came back almost instantly. And we're now just waiting for the other one to come back, and it's finally come back, and you'll see that there's this messages tab appeared in Management Studio. And in this, these are the IO statistics here. So what it's telling you is there was 1 scan made and 16 logical reads. And the second one made 244,000 logical reads. Now, when we're doing database performance tuning, typically we look at the logical reads and not the physical reads, and I'll explain the difference between those two. So a logical read is where it hits the cache and asks for a page back, whereas a physical read is where it hits the cache, asks for a page back, it wasn't in the cache, and it had to go to disk. The reason you look at logical reads is that typically you're doing this on a dev system, or it's quiet and you're allowed to run queries now, which means there's often nothing else in the cache. So you running a few queries is liable to skew your results. If you're looking at the physical reads, you won't get what's going to happen under business conditions when the system's busy, unless you load it up. But logical reads tell you what that performance would probably be, very, very close to accurate. So always look at the logical reads as a good measure of how much disk I/O you might actually expect your server to do. And remembering that disk I/O is what slows database servers down typically. That's normally the most common bottleneck in a database server is I/O, which is why we're looking at the logical reads here. Okay, so moving on to our second technique. Again, this is a really simple technique, and it's one that if you sit through things like JK, who's sitting up the back here, he has a presentation on how to use EF Core, and one of the things he talks about is that everyone always has a tendency to select every column out of an object and not just the fields they want, and that's really inefficient. And the same is true further down at the database layer. You're much better selecting just the fields you want rather than using select star to pick all of the columns in a table. I mean, select star is fine to use if you're just exploring and you're in Management Studio, you just want to see what's in the table. That's fine. Don't use that in your queries if you can. And one of the reasons is that retrieving all the columns can end up, you have to read the index, and then you've got to read the table itself, which is stored in a separate piece of disk. And you're just upping the amount of disk I/O. That's in the worst case. But even if you are reading the raw table, it takes more network to transmit more data. it takes more CPU work at both ends to encode and decode that data. And if you're just going to throw it away, that's not a great solution. So, here's an example of this, and we're going to generate a contrived solution. So what we're going to do is we want to get the display name and location out of the users table. So what we're going to do is create an index that has the display name and location in it. So if you wanted to fulfill that query, actually all SQL Server would need is to go and read that index. It could get all the columns you wanted out of that index. It doesn't have to go to the main table, which might have, say, 50 or 60 columns on it. It just has to go to that index that has 2 columns. So we're about to run it, and away we go. And this one takes a little while, so I'll have a sip of water. And it's taking even longer than expected. Now, what we're going to see here is we're going to get an execution plan back. So we press the little button on the toolbar that says include actual execution plan to get that. And what we see, if we expand this up a bit, is that the first one read from pk_users ID, which is the primary key, which is the main table. So it read all the data out of the main table. The second one only read out of the index display name _ location, and you'll see it took 0.35 seconds instead of 0.77 seconds. So it was twice as fast to read from that index instead of from the database table. And if we look, we can see why, because we've got our I/O statistics again. We did 44,000 logical reads in the first one and only 12,000 in the second one. So we would expect roughly a 2 to 3 times improvement in performance based on those numbers. Okay, so let's move on to our third technique. This is the hardest technique to implement. It generally gets you the biggest wins, which is why it's up towards the top of this list. Like, this is the one where you'll get huge wins, but it takes a lot of effort. And in reality, you can get up to, or sometimes in excess of, 1 million times performance improvements. If you've got a lot of data and you're scanning all of that data, instead of being able to go binary search straight to it, which is what an index allows you to do, then you can find that you really do get 1 million times performance improvements. And I did have a client where we got something like this. So what happened was we built this brand new system for them, and then we had to import and transform the data out of their old database system. So what we did was built some transformation scripts and started executing it, and sort of timed how long it was taking to process X number of records, and then calculated how long that experience was going to take. And I had to go back to the manager the next morning and say, well, we're going to need to optimize this a bit. Currently, it's looking like importing your 30 years worth of historical data here is going to take us about 36 odd years. Can we spend a day or two putting in some looking at indexing and seeing if we can optimize it that way? And they gave us permission to spend that day or two, and we got that time down from 36 years down to 8 hours. And the customer's quite impressed. They didn't think we'd get down under sort of, a week or 2 weeks or maybe a month. So that was an impressive win, but that just shows you how effective indexing can be on very large data sets, because that was an enormous data set with probably billions of rows in each of the tables that we were joining together. Okay, and if you want to learn about indexing, I'm not going to cover anything more about indexing here because it's a very involved topic. We could talk, and in fact there is a presentation in that GitHub repo, which will pop up the repo again later, where there is a full 1 hour sort of length presentation on how to do basic indexing. Okay, so we've created some indexing. indexes. What's the next most valuable thing you can do? Well, that's go, well, I've created all these indexes. Check whether they're being used, because the number of times you come into a client and they say, well, we've indexed everything, it should be great, and it's not performing, and the first thing you do is go and look at which indexes are being used and which ones aren't, and pretty much none of the indexes are being used because they were done backwards or on the wrong columns, so they didn't match what the customer was trying to do. So the easy way, if you're able to run the query in Management Studio, is just to run it with show actual execution plan on, and it'll give you back that execution plan that we saw earlier, and you can check that the plan uses the index you expected. Or a better one, because sometimes you find it's gone and chosen an even better index and you go, oh, I didn't think of using that index. So we're going to show you how to do the execution plan, and the more useful one here is how to query the index usage stats so that you can identify which indexes are being used in things. So we've got a pretty simple query here, and it's select star from DBO posts where the owner user ID equals 22, and you get a few rows back. But as you can see here, we can tell that it uses a non-clustered index, and then it goes back to the primary key to read some of the data. But it is using an index here. So that's a good bit. But how about if we can't run this query in Management Studio? It's being run by our system, and we just want to know what's going on. Well, this query here goes and selects a whole bunch of columns from sys.dm db index usage stats, and that is what's called a dynamic management view, and that's got how many times each of the indexes is used for a particular purpose since the server last started. So what I would typically do is run this query once, then make the activity I think should use the index run, and then run it again and see if the numbers have changed. And that's where we're just about to do that. So you see we've run it, and we've got our query in the middle there, and then we've got the same query again to grab the index usage data, and in a second we'll run it. And away we go. So just select it all and run. And what you can see is we get back the first set of results has 2 rows, one for each index, and it's got the index ID, then it's got the user seeks, the user scans, the user lookups, and the user updates. And what I can see is that between the first run and the second run, there was one more user seek in the top index. So that means that that query that I ran in between, because there's nothing else running on this server, used that index. So you can use that to verify what indexes are in use in your system. So that's a very useful query. There's a bunch of filters on that particular example, and you can pick out various types of indexes and all of that sort of stuff if you want to filter it down, because many servers have tens or hundreds, maybe even thousands of indexes defined, so you will get a lot of results back. Okay, so here's another one where you can end up with a query and you look at it and go, I don't understand why that query takes so long. It looks like it should run really fast. And what it'll be is you've got a where clause. Make sure the type of what you're searching for in the where clause matches the underlying column. So if it's an integer column, make sure you search for an integer. If it's a string column, make sure the thing you're passing is a string. And it can make SQL Server scan a whole index, as we'll see in this example here. So what we have here is we've got the post ID in DBO vote string is a string. If I go and search for the post ID as a string, that query is almost instantaneous to return. However, if I search for it as an integer, what it's going to do is go through each row and convert the value in this column into an integer, because like there's lots of integer representations of 9997, like you might have leading zeros and stuff. So it's got to go and check every single row to see whether it when converted as a string to an integer, whether it equals the value. And you can see it's going through all of it. It's then got this parallelism, which is actually the conversion to an integer, and then the comparison, and then the rest of it doesn't take very long. It's that whole seek through the entire index to find the couple of rows you wanted is what's taking all the time. So be aware that typing is just as important in a database as it is in your code. Like, if you get the typing, there's reasons we use strongly typed languages, and that's why we use strongly typed databases. Because here, we did 200,000 logical reads instead of 20. So that's 10,000 times more expensive because we got the type wrong. Okay, so another one that people tend to do is you can actually write loops in SQL. If you can avoid it, don't, because they have to run one after another. And so it won't be parallelized. So that's problem one. And really it's not what databases are designed for. They're designed to do things like aggregation and data selection. They're not really designed to go and iterate through something. They're basically a giant storage engine underneath. And storage engines aren't really good at going round and round in circles. Be aware there are times when looping is necessary, and looping through to get each database. So if you've got an database instance and it's got lots of databases in it, if you need to go into each one, typically you need to loop and say using and go into the new database and so on. But that's one of the few times. It's not often necessary to do looping. And here's a sort of contrived example, and this one's doing actual, it's just doing a loop to count the total number of posts and the total number of answers. By walking through, it's creating a cursor and going, I'll go to the first row, I'll add the total number of posts because it's a post row, and then I'll add the number of answers that it says are on that answer row, and we'll just keep going round and round and round and round. And then we'll close the cursor, and then we'll divide the answer count by the total posts. And then down the bottom, we've got the simplified version. We select the count, brackets answer count, and the average. We've got to cast it so that it comes out as a float because it's an integer, and it'll give you an integer number back, which isn't great for that one because it's normally the number's somewhere between 3 and 4, so like you do want some decimal places. And we've now run this query, and you can see that for every execution, it's gone and made a separate query back to the table to get the data for that one row, and then moved on to the next one, and then the next one. So we've just doing 10,000 rows was enormously expensive, whereas the second one, it just read through all the rows, didn't pause the execution, it just kept going and going and going and going, and it just scanned through and did it hyper efficiently. And the execution time, if you watched that, if you saw those two executions come back, the first one took about a minute, and then the second one, while we were talking, took 2 or 3 seconds. Okay, so our next technique, this is another one that you may not think is as bad as it is, but when you think about what the database engine has to do underneath, it's suddenly apparent why this is true. If you can use ands instead of ors in your where clauses, if you can. And why do you think that might be? Think through how an OR works. The server needs to go and grab all the data that fits clause A, then it's got to go and look through the whole table again and find all the things that match clause B, and then union the two together and then return that to you. And that's why you often see these an OR written as a union, because it's actually more efficient to do it that way. But if you do an AND, you go and find all of the results that fit clause A, and then, because it's an AND, they must fit clause A, so it's only those results could be returned. You then filter that result, which is generally much smaller, based on the second clause. So you've reduced the amount of work the database is doing dramatically by having an AND, as opposed to an OR where you've got to grab both sets and then join them together. If you have to do an OR, it's more efficient to write it as a union, because the optimizer will do a better job of working out what to do. And we'll see that example here. So here we want to select the number of downvotes by location for a user, the number of users who've got downvotes, more than 5 downvotes, or they're from America. I want to find all the people who are from America, or people don't like their answers. So let's run this query, and you'll see we get slightly different, the results in a slightly different order because I didn't order it. But you'll see that we do about 1,600 logical reads for the first one, and the second one does about 500. So it was about 3 times more efficient. Normally you don't get that level of improvement. This happened to be a good example, but it's always, the optimizer will always do a better job of working out what to do with a union than what to do with an OR. It will always try and do the, I forget which one it is. It'll try and do it in a certain order and then order them, and it doesn't do a terribly good job. Okay, so moving along, the next thing to avoid if you want good performance from your database system is avoid really large writes. And the reason this often causes you problems is that for every row you're updating in a large write, it'll lock that row for update, so no one can read from it. If you've got, say, 10,000 rows, it's going to try and create 10,000 locks. At some point it's going to go, oh, I've got too many locks on this page, this particular page in the database, I'm just going to escalate that to a whole page, so no one can look at that page suddenly, and then it may escalate from that to the whole table. But what happens is typically you start getting contention when you've got a large write, because no one else can read or write from large chunks of that database. Typically using bulk insert libraries, you can avoid some of the pain here, but even then, it's still not great. And the other thing to be really aware of is the more foreign keys attached to or from your table to other tables, it's going to be going and checking that those rows exist as it adds them. So that means all of those tables are getting hit as well. So the more foreign keys, the worse this gets. And the more indexes you have on the table you're updating, the worse it's going to get too, because it's got to, not only does it have to lock the main table, it's got to lock each of those indexes that have columns that are referenced by your write to go and modify those indexes based on what's getting written in there. So if you've got lots of indexes, typically a big write is generally a huge problem, and you want to do it out of hours or at times of low load, so you can just lock the whole table, write it in and unlock the table, or do something like that. So planning for what you're going to do if you have something in your system that's going to need to do lots of writes or big writes is well worth getting some advice before you go too far down that direction. Okay, so our next technique is another one that, you know, people don't think of, but is really quite a problem. Avoiding the wildcards at the start of string filters, i.e. don't use like %, which is the wildcard in SQL Server, or in, I think it's in ANSI SQL. % means wildcard, so it's like a star in a file match. So that means ends in Fred. For end with, if you know you're going to be doing that a lot, reverse the whole string, stick it in a new column, and index on that column. But only if you know you're going to have to do this lots. So for instance, if you know you're going to be looking for the end of someone, you know, for license plates, I know that police tell you that it's often the last digits of a license plate are the ones that people notice in a crime. So they're often looking for the last digits in a license plate instead of the first ones. So for that license plate example, you would probably want to do this. And if they've got the first few digits, you use the normal index and have an index of the license plate reversed and do it, index it on that. Anyway, we're going to do an example here, and we're going to look for posts where the title starts with Y. So the ones that are Y questions, and then we're going to look for ones that end with statement. So we're going to see how long that takes, and then we're going to look at, we've added a column called reverse title, and we just reverse the statement we want to look at to grab it. So, and away we go. And you'll see it doesn't take too long. But that middle one took the longest, didn't it? And if we go and look at the counts, we can see why. The first one did about 1,700 logical reads because it was able to go and search straight to the W's in the posts, because we've got an index on title here, and then grab just the things that started with WHY and just return that tiny little block. So it didn't have to seek very far. But for the one that's a % statement, it doesn't know where those are going to be in that index. So it's got to go through all of them. So it did 103,000 logical writes. So it's like 500 times less efficient. However, when we reversed it, we got it back to 120 logical reads, and that's because not very many things end in statement. There's a lot more things start with Y. Judging by those stats, about 10 or 15 times more things start with Y than end in statement. But that shows you how you can make an efficient way to search wildcards when they're at the end of where you need to find the last characters in a string. Okay, so another one is create joins within a joins. You can actually create them with a where, which is horrible to read. You can convert most of those wheres to joins, but not all. The reason you do it is this is not so much a performance one, although optimizers don't optimize joins done with a where clause as well as they do with joins. They're hyper optimized for joins, so there's more effort put into optimizing a join by most of the database manufacturers than a where clause, because they're often the most expensive thing in the system. The other thing is, it makes it clearer what type of join you're doing. Like, are you doing an inner join where you just get all of the stuff that matches in both sides of the join, or are you doing an outer join where if the row doesn't exist in the second clause, you still get nulls for the second table's values? So it's much easier to be clear about what your intentions are. So here we're trying to do, grab the users, grab the posts for that user. So on owner user ID, so the post's owner is that user, and where the user's location is in the US. So they're not terribly different, except to me, I can understand that second one, that join clause is joining those two tables together, and the where clause is about how to filter the information once I've done it. So it's split it up nicely for my logic, for my brain to actually cope with it. There's not a great deal of difference in the I/O performance in this example, but it does show you very clearly the difference between those two statements and how it's much easier to read that second one. Okay, so here's a one that's worth learning, not just for databases, but people have a tendency to do this in .NET code in particular, where they use .count is greater than 1, greater than or equal to 1, instead of doing .any. .any and exists in a database context. They stop as soon as they find the first match. So if there's a million rows and the first row matches, they'll read the first row and return. If you're using count is greater than 1, it's going to go all the way through the million rows to find out how many of them matched and count them for you, and then return and go, oh, they just wanted to know whether it was bigger than 1. And that's why you shouldn't do that. So remember that for C#, .NET. In fact, almost every language people tend to do it, but I do notice it more in .NET because you've got link. Makes it more common that devs make that error. But count greater than 1 doesn't. And that's what we're getting at here, is that count greater than 1 is really inefficient. Okay, so let's see just how inefficient that is. So again, we're going to set the statistics IO on. So I think I'm drumming this one every time. We grab the IO statistics because they're the most useful way to know what on earth's going on. And now we go and run it. And we'll see that first one, where we did the count, took 1,773 logical reads. And it only took 4 logical reads to figure out that there was a quote, one that existed. So it was enormously more efficient to do the exists. And now what happens in the null case where it does have to do everything? You'll see it had to do 5 logical reads for one and 4 for the others. So there's not much different in the case where exists came out as false, but if it did exist, exists is way more efficient than count. Okay, another thing to avoid is select distinct, which is generally, I think Oracle is the only database engine that actually optimizes select distinct, because you may as well just do a group by instead. You get the same effect, and you can get data aggregations as well. Because what happens with a select distinct is it'll grab all the results, then it'll sort them to eliminate, so it can then join up and eliminate all the duplicates. Whereas group by will do it as a much more efficient way and read it into a temporary bit of memory, or maybe into a temporary table if it needs to on some engines. And let's see just how long that's going to take. So again, we're going to set statistics IO on, and we're going to grab the user ID where they've got more than 5 answers. And the second one, we're going to grab the owner user ID, and just to show that we get another advantage, we're going to grab the average answer count as well, which we can't get with the first query while we're at it. And you'll see it takes a little while to grab the first one, and the second one was actually quicker it looked like. And there's not a great deal of difference between the number of logical reads there. But that improvement does often increase. But the other advantage is you got the ability to do aggregations while you're at it. You could have counted them, you could have done averages, mean, there's all sorts of nice aggregation functions available that you can get there. Okay, so this one here is a bit of a rule of thumb. Devs have a tendency to go, oh, I can just keep joining things and joining them and joining them and joining them and joining them, because like in your code, it doesn't look that like it's that hard. But what happens is you then send that to the database engine, and the first thing it does is compile that query, and then it sends it to what's called the query optimizer. And the query optimizer has to work out what's going to be the best way of getting back all the data you asked for. And once you get past about 4 to 7 joins, the query optimizers really can't search. What they're doing is a heuristic search through a giant search space. Once you've got 4 to 7 joins, they really can't search that search space well enough, and generally they'll just give up and they'll return the brute force, or very close to a brute force way of doing things. So they'll go and scan tables, they won't use indexes, they won't do it in the right order, and you can end up with very bad solutions. So if you're interested in how you can avoid that, if you take a look at JK, who's one of the other engineers here at SSW, he does a talk on how to write EF core queries, and his techniques for how to split queries into 2 parts, and you do a bunch of joins in the first one and then a bunch of joins in the second one, and then join those 2 together once you've retrieved the results, generally gives you a much better result. So check out his presentations on EF core as well. Okay, number 14. Do you know what I've seen crash a production instance? Is someone comes in and says, oh, we're in trouble. What? The database is performing really poorly, and the poor developer's grabs out Management Studio, signs into the production database and goes, well, how many customers have we got? Select star from customers. And suddenly they're grabbing all 5 million rows, and that's doing all the database I/O to try and read all those 5 million customers. Whenever you touch a production instance, always use top to make sure you're not getting too much data back, because the worst thing you can do is accidentally enumerate a giant table. So something like select top 100 star from customers would allow you to see, here's what a customer record looks like, here's what data's in it, here's the columns that we seem to populate. You might even grab the most recently added ones and the oldest ones to see how the database structure, what's filled in the database structure changes over time, but don't grab all the data. That's going to end in tears, particularly on production servers. You want to avoid grabbing more than a few rows at a time, particularly a database production server that's under duress, which is normally when you're allowed access to a production server. Like, most developers will not be allowed to touch a production server until something's gone wrong. So you don't want to be touching that and causing more issues by doing something that's really expensive at that time. You want to make sure you sample. Yes, and do not combine it with an order by unless there is an index on that column, and you want to be very sure that index exists before you do it on a production server, because otherwise it's potentially got to search the whole table and figure out what the top 10 rows are. Okay, and our final one of the techniques is use where when you can instead of having. And this is about knowing what where and having do. They do almost the same thing. Where is before you grab the data. Having is once you've got the result set prepared, then go and filter what's come back and filter it at that end. So where is filtering the data as it comes out of the raw data store, so you can use an index. Having, you can't. So the performance difference between where and having is generally of the order of, you know, thousands to millions of times worse to have a having clause. But sometimes you need to. So for instance, you may aggregate a whole bunch of data, like figure out what the sales are for all of your customers, and you might say having sales of greater than, you know, $1 million this year. You can't get that until you've aggregated how much sales each customer has. So you have to do that after the execution. But if you could do it before, like if you could cut down the number of rows with a where, so if we wanted only the customers who've got less than $1,000 in sales, well, anyone who has a sale of less than 1,000, of greater than 1,000, can't be in there. So I could do a where sale is greater than 1,000, is less than 1,000, just to cut out all the big customers who've got big sales instantly, and just grab back the ones that are small. But you can't always do that. So this one you can sometimes, and sometimes you can't. Okay, so let's recap all of those techniques we've seen. So we've got the big three. Reduce the size of your tables as much as you can. The second one, only grab the columns you want in any given query. And the third one, create indexes. And then we want to verify that our indexes are actually being used. That's super important because that's a very common thing to do, create your indexes and then never use them. And avoid those implicit type conversions and those loops, because they're generally a very common way of consuming a database's performance. Use and instead of or, and avoid doing big writes. We want to avoid wildcards at the start of filters. And we want to use join over where we can. We want to use exists and not count is greater than 0. We don't want to select distinct or do too many joins. And we want to use top for sampling, particularly when we're in a production environment, and use where instead of having in every situation that we can actually do that. Now this list of 15, this is a great one to stick up on the wall and hammer into your developers. These are the things we should get right from the start. Let's not make these errors. And then if we see performance issues, then we probably may need to get help in. These are the ones that typically, if you get help in, they'll find these sort of ones, spend all their time fixing all of this for you, and not get to the stuff that's actually hard, that would have been hard for you guys to fix. Okay, so we've got a bunch of resources that are useful if you're wanting to learn a little bit more than what we've covered here. So the first is Brent Ozar. Brent Ozar is a SQL Server master, which is a title Microsoft used to give out back in the old days before the MVP program. They used to have masters as well. And Brent, in my view, does the best training you can get in databases. He's also very easy to watch. He explains it really well, and he's got a bunch of free content on his site. He does then have training courses that you can elect to pay for, and he also presents at a lot of conferences. So there's a lot of videos of him at conferences and SQL Saturdays around the place. that are really useful and interesting. A second place is the SSW rules. We've got a bunch of rules to better database performance. Most of them cover all of the material we've seen here, plus a bit about how you can identify what the performance issue is, whether it is in fact, as we focused on here, database I/O, or whether it's memory or CPU, which are much less common problems, but you can consume all of the CPU on a database server, and that can be your bottleneck. But most often, a database will be bottlenecked on what it's supposed to be doing, which is reading and writing stuff from storage. That's what a database is for. So that's what you want it to be bottlenecked on. You want it to be bottlenecked on useful reading and writing of data, not wasteful reading and writing. Stack Overflow has lots of great stuff as well. Now, I'm going to call out exactly the database that we used here. That link there gets you to the raw Stack Overflow databases as, I think it's JSON, or is it XML? No, I think it's XML format. It's horrible to download, horrible to work with. Brent Ozar, who I mentioned earlier, keeps a ready-to-deploy SQL Server database that you can just download of that. And he's done it at various times. So you remember I said, see, I was using the Stack Overflow 2013 database. That was all the posts to Stack Overflow up to 2013 in that database. He's got one from 2008, 2013, and then a full one from very recently. And depending on what you're wanting to do, if you're wanting to just learn that the 2013 database is about the right size, if you've got a huge, great big box and you just want to see what it's capable of, grab the most recent one. Or if you're running it on a tiny underpowered laptop, just grab the 2008 database, and it doesn't have too much data in there, so it gives you the ability to play even on a tiny little underpowered machine. Okay, and then we have what I think is the best piece of database training I've ever seen, and it's called Think Like the SQL Server Engine. And it's again by Brent Ozar, and he walks you through how a database server actually tries to execute your queries, and by walking you through it as if it were and making you do it yourself by hand, you get a great understanding of just what operations are going on and why, when you try and do this particular query, you're able to look at it and go, oh, I know what that's going to do. I know why that's slow. And that's how I can fix it. Because you actually understand the process the server's going through, and you can then refine it and go, all right, yeah, I understand now. Here's how I'll approach the problem. So it lets you formulate answers because you actually understand what the server is doing. So that's a great piece of, that's a great resource for getting started and understanding the real basics of how a database works. Okay. Thank you for your time. All right. Okay. Does anyone who's here in person have any questions?
I have two. So you're mentioning, like we talk about ands and ors, how like with an and, some data is fetched, and then the second part of the and is then effectively applied on that data set. Would the order of the clauses in your ands make any potential performance differences?
Okay, so Gordon was asking us, when you've got multiple ands in a where clause, does the order you place them in that clause actually affect the performance? And the answer is, it depends on what database engine it is. So SQL Server, the high-end database engines have very accurate statistics on what's in tables and indexes and what the distributions are. So they will be able to pick out with this, whether this clause is going to be more, reduce the search area more than this clause, and it'll go to the most effective one first. Some things like SQLite won't do that. I think MySQL does these days. Like a lot of the free databases don't have that in their engine, or have a much less sophisticated way of doing that optimization. So the optimizer, typically when you're buying a database, that's really what you're paying for, is that query optimized layer is one of the key features you're buying when you buy those high-end databases. So they tend to be better in the better databases. So SQL Server will definitely pick the best order. Oracle will as well. Other ones, your mileage will vary.
And the other question I had is, you mentioned like you say a support engineer and there's production issues, always use a top to limit the sort of results that you get back. Would using like with no-lock hints help at all in that use case?
Okay, so Gordon's asking, would a no-lock hint help when you're trying to do sampling? So I'll quickly explain what a no-lock hint does. Is it will read and it won't take out any locks to avoid anyone writing to that data while you're reading it. That's the basics of a very simple way of explaining it. It's slightly more complicated than that. It would probably cause a little bit less contention, but if you've got contention on that table, it means there's probably a reasonable chance that some of that data might get overwritten while you're reading it, particularly if you're looking at grabbing the most recent data. If you're grabbing all the oldest data and it's rarely updated, you're probably fine. But again, you probably wouldn't be getting contention on that. So no-lock's considered kind of hairy to use, and that's because you won't get consistent data necessarily. Okay. Nick has a question.
How often do you see loops in the real world?
Okay, so Nick's asked, how often do you actually see loops in the real world? I think they're becoming less common, but more often than you would think. Like, a lot of people don't think of the aggregation instructions in databases. They'll just create a cursor and sit there spinning. It's not often you need to do that. Like, there's not that many operations that you can't do with the aggregations and the built-in functions in most of the database engines. So yeah, it happens more than you would think. So just a bit of background is where with these 15 things came from was these were the 15 things that every time someone used our performance monitoring product, these were the 15 things you could, pick out of every customer had at least 5 of those things causing them an issue. So they're ridiculously common. They're the mistakes that everyone makes. And if we just eliminate those, the amount of time we have to spend on, maintaining databases would be significantly reduced. It won't be eliminated, but it would reduce the problems many, many applications have. JK has a question for us from right up the back of the room. Okay, so JK is going to ask us 2 questions.
So, what if we have chronological data that increases ascending, but you mostly carry the data from the latest to the oldest? Should we create an index that is sorted in the opposite direction?
Okay, so JK is asking if you've got chronological data and you commonly query it in the opposite direction, should you create an index in ascending or descending order? And the answer is these days it really doesn't matter very much. It used to matter quite a lot because a lot of the optimizers wouldn't figure out what was going on, and optimize it very well. I'm trying to remember, there are reasons to do it. It's normally about having different columns going in different directions rather than the whole index. So if you're wanting to be ascending on user ID and then descending on version or something, that's where the ascending, descending is useful because it groups things together in the right positions. Much more than just the single ascending, descending on a primary column. And second question from JK.
So if joining is preferred for wake clauses, can we just filter things as part of joining? Can we just join with any columns, or they should be foreign keys indexes?
So JK's question is, can you join on things other than foreign keys? And the answer to that is yes, you can. Your mileage will vary because you may or may not find those values in there, or typically the reason you do it with a foreign key is the point is that there will be data there, absolutely. Whereas typically with an outer join where you accept nulls in what you're joining to, much more common that you would do something that's not a primary key there. So you might do a secondary key, or you might do someone's name, or it doesn't have to be a key then as much.
To elaborate the question, should you just move filtering into the on segment?
Okay, so JK's asking, should you move filtering into the on? Not if it's not between the two tables being joined, the tables you're actually trying to join.
So you could say join all of the invoices that are more than $5,000.
Yeah, like don't do that. That will confuse the optimizer really badly. Just the same way that putting the joining pieces in the where clause confuses it. Yeah, so JK was asking, can you actually just chuck the filters into the join piece? And the reason you wouldn't do that is that the optimizer's looking for the filtering in the where clause, so it knows which bits of various tables to grab, and it's looking in the join to know how it's got to join tables together. So they're being used for very different purposes, and the optimizers have been written to pick the stuff out of the join and work on joining tables together with the data, the information that the query writer has written in the join, and it's trying to do the filtering based on what's in the where clause. So don't get them mixed up. That's
this is just a fun one. You can do distinct by making a union of the same query.
yes. So JK was saying you can make a distinct by doing a union of the same query. Okay, and I think, oh no, we've got one more question from Gordon.
Well, question online from Richard. What is your opinion of Azure Data Studio and are you using it?
Okay, so we're being asked, what is our opinion on Azure Data Studio and am I using it? I personally don't use Azure Data Studio, but that's because I've got like more than 15 to 20 years experience with SSMS, so I'm very, very set in my ways. For some purposes, Data Studio is better, and some purposes, Management Studio is better. The plan viewer in Management Studio is still better. There's better plugins still for Management Studio, but I think over time, Microsoft is wanting to move all of that function into Data Studio because it's a bit more portable. So they can port it to other environments much more easily than they can port Management Studio, which is very x86 based. JK.
Yeah, and you can run GitHub Copilot in Data Studio.
Yes. So JK was pointing out you can run GitHub Copilot on Azure Data Studio if you want. And we might have one final question from Luke. No?
I was just going to say
Yes, and there's full dark mode in Azure Data Studio if that's something that you like.
Which also Bryden sets in his ways.
Yes, that's another one that I'm very set in my ways. I will always choose light mode. All right, so thank you all for the questions. It's been good fun answering a few questions. All right. Cheers, and thanks everyone for tuning in. We'll catch you next time.